covering climate, weather, and the industrial enterprise from Penn State Meteorology. Here is Up in the Air.
Welcome to this week's episode of Up in the Air. I'm Kasey Rigner.
And I'm Ryan Gold. We've got a very informative show for you today with stories about dinosaurs and carbon sinks in oceans.
We also have a feature from our very own Joe Spear about wildfires and air pollution. All that and more, but first, here's Update in the Air.
Buried for 66 million years, a prehistoric graveyard in the Hell Creek Formation reveals what happened in the minutes after a giant asteroid slammed into the Earth and wiped out the dinosaurs. Perfectly preserved fossils of fish, animals, and plants at the site offer a detailed recording of what happened immediately after the asteroid struck off Mexico's Yucatan Peninsula. The impact created a giant crater and ejected tons and tons of vaporized rock and dust into the atmosphere. The subsequent cloud led to the extinction of 75% of life on Earth. Thousands of tiny glass beads formed by the impact rained down on the site, and some of those beads were inhaled by the fish in the inland sea and discovered in the gills of the fish at the dig site. The impact also caused shock waves that sloshed the inland sea, causing many other marine creatures to be washed up onto the sandbar. While no dinosaur fossils were found yet, it is only a matter of time. They have been waiting for 66 million years, but we could find them in the next few.
Not all of the carbon dioxide generated during the combustion of fossil fuels remains in the atmosphere and contributes to global warming. The ocean and the ecosystems on land take up considerable quantities of these human-made CO2 emissions from the atmosphere. The ocean takes up CO2 in two steps. First, the carbon dioxide dissolves in the surface water, then the ocean's overturning circulation distributes it. The ocean currents and mixing processes transport the dissolved CO2 from the surface deep into the ocean's interior, where it accumulates over time. The driving force behind the oceanic sink for CO2 is this overturning circulation. The sink size is very important for atmospheric CO2 levels, and without the sink, the concentration of carbon dioxide in the atmosphere would be much higher. This percentage of CO2 taken up by the oceans has remained relatively stable compared to the past 200 years. But the absolute quantity has increased tremendously. As long as the atmospheric concentrations of CO2 rise, the oceanic sink strengthens more or less proportionally. Research results suggest an intact ocean sink for human-made CO2. By moderating the rate of global warming, the oceanic sink for man-made carbon dioxide provides an important service for humanity, but it comes with a price. The CO2 dissolves in the ocean, acidifies the water. This can have serious consequences for many marine organisms. Calcium carbonate spontaneously dissolves in acidified environments, which poses a threat to mussels and corals whose shells and skeletons are made of calcium carbonate. The changing chemical composition of the ocean can also impact physiological processes such as the breathing of fish. The chemical changes imparted on the ocean as a result of human activity is crucial, as well as the changes on marine life.
It's a bird, it's a plane, it's electricity. The world's first all-electric airline will soon be taking passengers to destinations in the Pacific Northwest of the United States and Canada. Harbor Air, North America's largest seaplane airline, and Magnex, a leading developer of electric propulsion systems for aircrafts, began a partnership to convert Harbor Air's entire fleet from more than 40 seaplanes to electric power. The new e-planes will be powered by a 750 horsepower electric motor and will use no fossil fuels and produce zero emissions. The DHC-2 de Havilland Beaver, which carries 6 passengers, will be the first in Harbor Air's fleet to be converted to electric power. Initial test flights are expected to take place later this year.
Tiny fragments of plastic in the ocean are consumed by sea anemones along with their food, and bleached anemones retain these microfibers longer than healthy ones, according to new research. This research is the first ever investigation of the interactions between plastic microfibers and sea anemones. Anemones are closely related to corals and can help scientists understand how coral reef ecosystems are affected by millions of tons of plastic contaminating the world's oceans. One of the most common types of plastic in the ocean are microfibers from washing synthetic clothing and from the breakdown of maritime equipment such as ropes and nets. Microfibers are found across all of the world's oceans and are beginning to appear in fish and shellfish consumed by humans. Most laboratory research on plastic pollution uses tiny beads of plastic, not microfibers. Researchers set out to determine whether microfibers are ingested by healthy sea anemones and by those that have the symbiotic algae that provide them with nutrients, a condition called bleaching. On coral reefs, bleaching is caused by increasing ocean temperatures due to global climate change. The research team introduced 3 different kinds of microfibers, nylon, polyester, and polypropylene, to both unbleached and bleached sea anemones, both alone and mixed with brine shrimp. It took longer for the bleached anemones to expel the microfibers after ingesting them than it did for the healthy anemones, although all microfibers were gone by the 3rd day. However, in a natural marine environment, anemones and coral would continually be reintroduced to new microfibers, making the contamination of chronic condition a part of their existence.
Hail as large as golf balls pelted a large area of central Florida Wednesday morning as heavy storms battered the region. There were reports of shattered windows, pool screens blown apart, and cars damaged. Piles of ice up to 2 inches high covered the ground in some areas along the Space Coast in Brevard County. Residents in the small town of Trenton woke up Wednesday morning to streets covered in so much hail that it looked like snow.
Off the coast of Washington, columns of bubbles rise from the seafloor as if evidence of a sleeping creature lie below. But these bubbles are methane that is squeezed out of the sediment and rises up through the water. The locations where they emerge provide important clues to what will happen during a major offshore earthquake. The first large-scale analysis of these gas emissions were along Washington's coast, where more than 1,700 bubble plumes were analyzed, primarily clustered in a north-south band about 30 miles from the coast. Analysis of the underlying geology suggests why bubbles emerge here. The gas and fluid rise through faults generated by the motion of geological plates and produce major offshore earthquakes in the Pacific Northwest. The authors of the research study analyzed data from various research cruises over the past decade that use modern sonar technology to map the seafloor and create sonar images of gas bubbles within the overlying water. Their new results show more than 1,778 methane bubble plumes issuing from the waters of Washington state, grouped into 491 clusters. Sediments are heated, deformed, and compressed against the rigid North American plate. The compression forces out both fluid and methane gas, which emerges as bubble streams from the sea floor. The bubble columns are located most frequently at the boundary between the flat continental shelf and the steeply sloped section where the seafloor drops to the abyssal depths of the open ocean. The location of these faults could potentially provide new understanding of the earthquake hazards from the Cascadia subduction zone, which ruptured more than 300 years ago.
Welcome back to the show. We now go to a feature from Joe Spear about air pollution and wildfires.
The fight for cleaner air is making some progress, but it's not enough. While steps have been made to reduce the amount of particulate matter in the atmosphere, wildfires can counter all of that effort. A study from Climate Central updated a previous study of particulate matter from wildfires in the California Central Valley, made up of the San Joaquin and Sacramento valleys, from 2000 to 2016 by adding data from the Pacific Northwest through 2017. The EPA has set a 24-hour standard of 35 micrograms per cubic meter of particulate matter, and if there are more, it is called an exceedance day. In the old study, the number of exceedance days had decreased, but during wildfire season in California, the number of exceedances was increasing. The trends were the same in the 2017 data. Before 2010, the Sacramento Valley had 47 exceedance days, and the San Joaquin had 90. From then to 2010, both valleys saw a decrease in exceedances, but the percentage that occurred in wildfire season had increased. The Pacific Northwest wildfire season has increased 105 days since 1970. Idaho has 10 times more fires a year, Oregon has 7, and Washington 5. In the new study, Idaho and Oregon saw an exceedance decrease, but Washington increased. The Pacific Northwest is seeing increased soil aridity, measured by the Keach-Byram Drought Index, or KBDI, that analyzes the dryness of the top 8 inches of soil and predicts the chance of a fire. Looking to the future, California could have 24 more high percentage days, Idaho 15, Oregon 17, and Washington could have 18, all by 2050, based on the KBDI. But climate change isn't the only factor leading to more wildfires. Land use conversion, logging, and agriculture all lead to a buildup of fuel and more arid forests. To lessen the impact of wildfire season on air pollution, we need to find smarter ways to prevent those fires. Only then can we breathe a little easier. For Up in the Air, I'm Joe Spear.
Welcome back to the show. Ryan, last weekend it was warmer, but it was a little bit wetter. We had some rain Friday, overnight Saturday and Sunday morning, and we woke up for, this was not an April Fool's joke, to snow on the ground Monday morning.
Yeah, April 1st has snow. Spring is giving us April Fool's jokes here, and I just want it to be nice and warm. Hopefully this weekend, Relay for Life is this weekend, and I just want some nice conditions to go out there and walk for 12 hours straight to help raise money for cancer research. Joe, do you have any good news for us?
Well, I might have some good news for you coming up in the temperature outlook and maybe even in the weekend forecast. But first, let's take a look at the climate info for April 4th. We have an average high of 55 degrees and an average low of 36 degrees. And our record high came in at a smashing 81 degrees back in 1910 and our record low 17 back in 1898. Now, as we take a look at the temperature outlook, this is for April 8th to April 14th. A lot of the country has a chance to be above normal in terms of temperature, but as we look over into the western part of the country, we see this small little outcropping of below normal temperature, and that reaches up into northern Nevada, reaching around the Great Salt Lake and even parts of southern Idaho. And as we head over into those above normal temperatures, we see a strong stretch from all the way over to Southern California down into Florida for that chance of above normal, and the highest concentration being over in the southeast, reaching down from Florida up into parts of Virginia. And now as we look in our region, we have a chance for above normal temperature, but it's not as strong as we've seen down in the south. Now as we take a look into precipitation, a lot of the country is also going to be experiencing above normal precipitation. As we look into the west, we also have that chance for above normal precipitation, and that strong concentration is also coming in northern Nevada and into the Great Salt Lake. And as we zoom over down into the south and parts of the east, we see that stretch also comes out from Texas and reaches down into Florida, where Florida has the highest concentration of above normal precipitation. And as we look up into our area, we're right on the cusp of normal precipitation outlooks, where we see that border coming up to our north and even farther off to our east. And as we take a look at drought, well, a lot of the country is going to be seeing above normal precipitation, so we might be seeing less drought in the coming weeks, but we have that trace of drought coming out in the Four Corners region. A lot of it's mostly dry, but we do see some exceptional drought up in northern New Mexico. And we zoomed out over in the northwest because we have been seeing that drought over in Oregon and Washington, but now we have a trace of it coming out from Utah and into southern Montana. And as we look down in the south over in the Gulf Coast, we have a strong chance of drought over in southern Texas, and it also reaches all the way across the Gulf Coast down into Florida. And in our region, not seeing any drought. Snow depth, we mentioned earlier that we did see some snow over the weekend, so we'll take a look at that in a minute, but we have the Sierra Nevada still experiencing some significant snow depth, and we also have that coming in over in the northern Rockies, but both regions are seeing a little less than what we've seen previously in the semester. As we see traditionally, we have some snow depth coming in over the northern Great Lakes, and then in our region over in New England, we have some significant snow depth up in northern New Hampshire and northern Vermont, but in our area, we didn't see any snow depth. Now, as we take a look in the weekend forecast, we have a 58-degree high on Saturday, mostly cloudy, and then on Sunday, we have mostly sunny with a nice 64. So if you're headed out for Relay for Life, Saturday and Sunday are looking pretty good.
Looks like a great weekend ahead. I'm not seeing any snow, and that's all that I was looking for.
Oh yeah, and I'm really excited about those temperatures. For Relay for Life, it's going to be a great day. Thank you for watching, and float with us next week up in the air.